On October 8, 2025, the European Space Agency, ESA, published a photograph that a majority of the globe glanced at and dismissed, not comprehending its significance. It depicted an indistinct white speck traversing a field of stars, documented by the ExoMars Trace Gas Orbiter from a distance of 30 million kilometers. The official statement was highly technical, exceptionally dry, and seemed almost to apologize for the poor visual quality. It noted a Cassis camera 5-second exposure. This was standard scientific jargon used to describe a truly unparalleled event. However, this is the information the press release omitted. 3 hours prior to that image's public release, NASA's own Mars Reconnaissance Orbiter was in the absolute perfect position to capture the very same object with a resolution 30 times greater. The HiRISE camera, to be specific, is capable of resolving details smaller than an automobile on the surface of Mars. It can literally read the serial numbers from hardware our missions have left behind. And yet, on October 3rd, when the interstellar object 3I Atlas cruised just 29 million kilometers past Mars, HiRISE was pointed precisely at that object. What we received was an indistinct white speck from the Europeans. What we received from NASA was absolute silence. And emerging from that deafening silence was something else entirely. This did not come from any official channels, but rather from the raw, unprocessed image feeds that NASA failed to terminate quickly enough amid the government shutdown. These were images that, once they were correctly processed, revealed something that simply should not exist. Before we delve any further, it is crucial you understand what you are about to witness. This is not, fundamentally, a story about an alien spaceship, although that specific hypothesis is something we will explore. This is, instead, a story detailing an object from a distant star system, which journeyed into our solar neighborhood possessing characteristics that seem impossible, traveled directly within the view of our most advanced cameras, and ultimately left us with photographic evidence that calls into question everything we believed we understood regarding natural celestial mechanics. Please let me know in the comments section what part of the world you are watching from, what the current time is in your location, and your personal theory on what is truly unfolding on Mars at this very moment. And if this topic is as fascinating to you as it is to me, please hit that like button and be sure to subscribe. Distribute this video to your friends and to your family members. We are all going to need one another for whatever is coming next. Chapter 1. The trajectory that should not exist. Allow me to demonstrate exactly why 3I Atlas disturbed astronomers from the very first moment of its discovery. On July 1, 2025, the Atlas telescope system in Chile detected an object moving through the constellation Sagittarius. The initial calculations indicated it could potentially pass near Earth's orbit. For a period of 6 hours, it was listed on the official Near-Earth Object Confirmation page. Sometime later, the numbers were returned, revised, and everyone monitoring it relaxed. It was classified, not a threat. It possessed a hyperbolic trajectory. Its interstellar origin was confirmed. This was the third confirmed visitor from outside our solar system. Following Oumuamua in 2017 and Borisov in 2019, you would think we should have been getting better at identifying these. But 3I Atlas was profoundly different, right from the beginning. Oumuamua, for instance, approached from the direction of Vega, penetrating our system at 26 kilometers per second, and it was tumbling chaotically. Borisov arrived from the area of Cassiopeia, traveling at 32 kilometers per second, and it behaved precisely as a comet is expected to behave. Both of these trajectories were steeply inclined relative to the ecliptic plane, which is the flat disk where all of our planets orbit. Oumuamua's inclination was 123 degrees. Borisov's was 44 degrees. These were random arrivals originating from random directions, which is exactly what you would anticipate from objects ejected from faraway star systems due to gravitational chaos. 3I Atlas, however, arrived at 58 kilometers per second, making it the fastest interstellar visitor ever recorded. But its speed was not the anomaly. Its direction was. Its orbital inclination was 175.85 degrees. This means it was in retrograde motion, traveling opposite to the orbital direction of the planets, yet it was almost perfectly aligned with the ecliptic plane itself. It had just 5 degrees of tilt. You must consider what that implies. The universe, after all, is three-dimensional. Objects from deep interstellar space can arrive from quite literally any direction. The statistical probability of a random object aligning itself within 5 degrees of our solar system's orbital plane is approximately 0.2%. That is 1 in 500. It is highly improbable, certainly, but it is not impossible. Except that 3I Atlas wasn't merely aligned with the ecliptic. Its trajectory appeared to be optimized in ways that made orbital dynamicists extremely uncomfortable. On its specific path through the inner solar system, 3I Atlas will perform close approaches to 3 separate planets. Venus at 0.65 astronomical units, Mars at 0.19 astronomical units, and Jupiter at 0.36 astronomical units. 3 distinct planetary encounters, all perfectly spaced along a retrograde flight path that necessitates only minimal course correction to arrive at each one. The probability of this specific configuration happening by random chance? 0.005%. Pause for music. 1 in 20,000. Avi Loeb, a Harvard astrophysicist and a very persistent voice within the interstellar object discourse, published his own analysis within just 2 weeks of the discovery. He did not call it an alien spacecraft in that initial paper. Instead, he labeled it anomalous. He pointed out that if one were designing a reconnaissance mission intended to survey multiple planets in our solar system while using minimum fuel expenditure, this is the exact trajectory you would select. Other scientists, quite correctly, pushed back on this immediately. They argued that natural processes are capable of producing unlikely configurations. The universe is incredibly vast, and it is filled with coincidences. A single object possessing a statistically rare trajectory proves nothing except that rare events do, in fact, occasionally happen. But that was before the chemistry data began to arrive. Chapter 2. The metal that should not be there. It was late August 2025. The Very Large Telescope, located in Chile, aimed its UVES spectrograph at 3I Atlas. This was a standard cometary observation. The team was searching for the usual suspects: water vapor, hydroxyl radicals, various carbon compounds, all the spectral fingerprints that inform us what a comet is composed of. Instead, they found something entirely unexpected. They found nickel. Atomic nickel vapor was streaming away from the object in quantities that were increasing exponentially as it drew closer to the sun. By the end of August, the concentration had escalated, following a power law of roughly 9. Every single incremental decrease in its distance from the sun was producing a dramatic increase in the nickel emission. That discovery, by itself, would have been interesting. Nickel, you see, has been detected in other comets before. It is not a common finding, but it is not impossible. However, here is the specific problem that caused the VLT team to pause before they published their data. They detected virtually no iron whatsoever. In the natural universe, nickel and iron are forged together. When a massive star detonates in a supernova, it creates heavy elements in temperatures and pressures that bond these two specific metals inextricably. Every single meteorite, every asteroid, and every comet we have ever analyzed displays them together. The ratio might vary slightly based on formation conditions, but they are always both present. 2I Borisov, the previous interstellar comet, exhibited normal nickel-to-iron ratios. Every solar system comet we've studied shows normal ratios. The cosmic abundance of these elements is well understood, and it is consistent across all known natural bodies. 3I Atlas was producing nickel without the iron. The only place on Earth we ever observe that kind of signature is in advanced industrial production. We create nickel alloys for electronics, for use in specialized machinery, for applications where the presence of iron would be a contaminant. This process requires deliberate, careful refinement, smelting, and chemical separation. These are things that simply do not occur naturally, especially at the frigid temperatures where comets are formed. The authors of the paper were exceptionally careful with their language. They referred to the finding as extremely puzzling. They went on to propose hypothetical chemical pathways that could, perhaps, under very specific conditions, produce this separation. They noted that the temperature at 3I Atlas's distance from the Sun was far too low to vaporize the kind of refractory minerals that typically contain these two metals. But you could practically feel the uncertainty in their prose. It was a subtle acknowledgement that they were observing something that did not fit any of the existing models. And this was only one anomaly. There were 6 more to come. Chapter 3. 7 Impossible Things. Allow me to guide you through what makes 3I Atlas unlike any object we have ever tracked through our solar system. This is not speculation. These are measurements, observations from Hubble, from JWST, from the Very Large Telescope, and from dozens of observatories globally, all published data that any person can verify. Anomaly. 1. The mass problem. When astronomers tried to calculate the size of 3I Atlas based on its brightness, they reached a figure that made no sense. If all of that illumination was just reflected sunlight, the object would need to be somewhere between 10 and 20 kilometers across. For comparison, Oumuamua measured barely 100 meters. 2I Borisov was less than 1 kilometer. Enormous interstellar objects are exceedingly rare. We should have discovered hundreds of Oumuamua-sized visitors before ever encountering something this massive. The statistical models are exceptionally clear on this. The probability is roughly 0.01%, 1 in 10,000. But then, the astrometric data arrived. Over 4,000 measurements from 227 observatories between May and September. When scientists compared 3I Atlas's trajectory to pure gravitational acceleration, they found almost zero deviation. Despite severe outgassing, despite shedding 150 kilograms of material every second, the object barely moved from its predicted path. This implies a colossal mass, a nucleus so heavy that even the constant jetting of gas and dust cannot push it from its course. The calculations pointed to more than 33 billion tons, a diameter exceeding 5 kilometers, making it roughly 1 million times more massive than Oumuamua. 1 million times. That is the gap between a single grain of sand and a massive boulder. Anomaly 2, the backwards glow. Hubble secured the highest resolution photograph of 3I Atlas on July 21, 2025. Scientists examining that image observed something that had never been documented in any comet, whether solar system or interstellar. The scattered light surrounding the object extended approximately twice as far toward the Sun as it did perpendicularly or away from the Sun. Comets possess tails that point away from the Sun. This is elementary physics, confirmed by thousands of observations over centuries. Radiation pressure pushes dust particles outward, always. 3I Atlas seemed to be violating this core principle. The extension was not minor. It was a 10-to-1 ratio, 10 times longer in the solar direction than sideways, and it was observed edge-on, meaning the actual elongation was even more severe when accounting for the viewing geometry. Loeb and his colleague Eric Kato published a paper suggesting an explanation involving ice fragments that sublimate at differing rates based on which side of the object they are ejected from. The physics was solid, the mathematics checked out, but it demanded a highly specific set of conditions never before observed in any other comet. A unique configuration that just so happened to manifest in an interstellar visitor already displaying multiple other anomalies. Anomaly 3, the industrial fingerprint. We have addressed the nickel without iron issue, but it warrants emphasis because it is not merely unusual, it is the kind of signature that makes material scientists deeply uncomfortable. The concentration ratio, the emission patterns, the temperature dependency. These are characteristics we link with refined alloys, not with primordial ice. Anomaly 4. Polarization from another world. When light scatters from particles, it becomes polarized. The degree and direction of that polarization reveal information about the size, shape, and composition of those particles. Comets have very characteristic polarization signatures. We have measured hundreds of them. The patterns are well established. 3I Atlas displayed a polarization signature that does not exist in any known catalog. Negative 2.77% at a phase angle of around 7 degrees, with an inversion angle of only 17 degrees. This specific combination had never been measured in any asteroid or comet, whether solar system or interstellar. The closest comparison was not comets at all. It was trans-Neptunian objects and a specific centaur named Pholus, icy bodies from the far outer reaches of our solar system with vastly different compositions and histories than typical comets. A paper submitted to the Astrophysical Journal Letters concluded that 3I Atlas may represent a distinct type of comet, expanding the diversity of known interstellar bodies. Distinct type is scientific terminology for we have no category for this. Anomaly 5. The ecliptic alignment. We have covered this, but it must be repeated with its full context. The solar system is, essentially, flat. Random objects from interstellar space arrive from random directions, crossing that plane at random angles. The probability of an alignment within 5 degrees? 0.2%. And 3I Atlas is not just aligned, it is moving retrograde, opposite to planetary motion. This is the ideal trajectory for surveying multiple planets with minimal course corrections. Anomaly 6. The planetary timing. 3 close planetary approaches: Venus, Mars, Jupiter, all with perfectly synchronized arrival timing. The probability? 0.005%. 1 in 20,000. If you were engineering a reconnaissance mission, this is the exact trajectory you would select. Anomaly 7. The WOW signal coincidence. In 1977, the Big Ear radio telescope detected a signal so strange that astronomer Jerry Eman scribbled "wow" in the margins. It originated from the constellation Sagittarius, lasted 72 seconds, and has never been found again, despite decades of searching. When scientists traced 3I Atlas's trajectory backward through the galaxy, factoring in its speed and direction, they calculated where it would have been in 1977, within 9 degrees of the WOW signal's origin. The probability of this alignment? Roughly 0.6%, 7 anomalies, 7 statistical long shots. And we are being asked to accept that they are all coincidences. This is the point where Occam's razor begins to cut in a different direction. One anomaly can be explained away. 2 might be a coincidence. But when you stack 7 improbabilities on top of one another, the simplest explanation ceases to be unusual natural object and starts to become something else. Not necessarily artificial, but certainly deserving of investigation with more than just dismissive skepticism. Which leads us to October 3rd, 2025. And what should have been the observation opportunity of the decade? Chapter 4. The day we should have seen everything. October 3rd, 2025, should be recorded in history books. The day humanity achieved its closest ever look at an interstellar visitor. The Mars Reconnaissance Orbiter was positioned perfectly. The HiRISE camera was ready to capture resolution 30 times better than anything Hubble could achieve. ESA's Mars Express and the ExoMars Trace Gas Orbiter were standing by with their full instrument arrays, 29 million kilometers. In cosmic terms, that is close enough to shake hands. The HiRISE camera, remember, can resolve features smaller than an automobile on the Martian surface. At 29 million kilometers from a 5-kilometer-wide object, it should have been able to determine the gross morphology, the shape, the surface features, the rotation characteristics. Not fine detail, but enough to resolve fundamental questions. Is it round, elongated, irregular? Does it display variations in brightness, implying different materials? Does it resemble other comet nuclei we have photographed? Or is it something else? These are not difficult observations for HiRISE. This is the basic scientific return expected from an instrument that cost hundreds of millions of dollars to develop and deploy. And then, at the precise moment when we needed NASA the most, 83% of the agency vanished. 15,000 civil servants were furloughed, gone, during what should have been the most intensive observation campaign in the history of interstellar astronomy. The official story was simple. Federal government shutdown, a budget impasse, nothing at all to do with 3I Atlas, just unfortunate timing. Unfortunate timing. Those two words are doing a great deal of work. Consider the odds. 3I Atlas was found in July. The Mars flyby had been planned for months. Scientists knew this would be their sole chance to acquire high-resolution images before the object vanished behind the sun. NASA knew, ESA knew, every space agency on Earth was aware. And in the final week before the closest approach, the United States government shut down. NASA's official website ceased updating. Press releases stopped. The army of scientists who should have been analyzing data, processing images, and making discoveries, they were all sent home. Only essential personnel remained. A skeleton crew, tasked with maintaining critical operations. But here is what makes it suspicious. Raw image feeds from the Perseverance rover kept uploading. The rover did not stop working. The Mars Reconnaissance Orbiter did not stop working. The cameras were active. The data was being gathered. It just was not being released to the public. An amateur astronomer, Dobsonian Power, a YouTuber with a solar telescope, posted an image on October 3rd with a simple caption, "What on earth is it?" The image revealed something dark, angular, embedded within the expected position of 3I Atlas. Within hours, the post had thousands of views. People demanding answers. People highlighting that if a backyard observer could capture this, what were the professional instruments seeing? NASA said nothing. ESA said nothing. The only official confirmation that observations had even occurred came from Simeon Schmaus, an astrophotographer who stacked 20 Perseverance images and found what he described as a faint smudge of light in the constellation Corona Borealis, close to the location where the comet was expected. A faint smudge. That is what we received from humanity's closest look at an interstellar visitor, from spacecraft that can resolve features smaller than a car on the Martian surface. Unless, of course, they observed something else entirely and made the choice not to show us. The European Space Agency finally did release something on October 7th. Not from HiRISE, which remained silent. It was from their ExoMars Trace Gas Orbiter. The CASIS camera had successfully imaged 3I Atlas during the flyby window. They confirmed multiple wavelengths, spectroscopic, data, and a series of frames depicting the object as it moved against the background stars. What they published was a fuzzy white dot, an animation showing it drift downward through the frame. No tail was visible, no surface features. Just a bright, slightly elongated glow against the darkness. The press release was careful with its language. The comet was around 50,000 times fainter than what the orbiter is used to viewing. Challenging exposure times, 5-second integrations, faint target against a dark background. All of this is technically true. But CASIS was not the most capable camera watching 3I Atlas that day. HiRISE was. And the HiRISE images, if they exist, have not been released. China's Tianwen-1 mission said nothing. The UAE's HOPE orbiter said nothing. Every spacecraft at Mars had been watching, and every space agency had gone quiet. You do not need to be a conspiracy theorist to find this strange. You just need to recall what occurred with 2I Borisov, the previous interstellar comet. When it passed through in 2019, images flooded out immediately. Scientists were excited. Press releases flew. The astronomical community celebrated. It was treated exactly as you would expect. A rare visitor from beyond our solar system, worthy of intense study and public engagement. 2I Borisov received fanfare. 3I Atlas received silence. The difference, perhaps, is that 2I Borisov behaved exactly like a comet. It had the right chemistry, the right tail, the right outgassing patterns. It was interesting because it originated from interstellar space, but it was not anomalous. It did not challenge our understanding. It did not raise uncomfortable questions. 3I Atlas does all of those things. And so, as it vanished behind the sun on its journey to perihelion, as it entered the one place in the solar system where no telescope on Earth can view it, the silence deepened. Amateur astronomers posted their final images. Scientists published their papers, carefully worded, technically precise, avoiding speculation. And 15,000 NASA employees waited to be called back to work, wondering what their colleagues with essential status had seen in those Mars orbiter images that the public was not being shown. Chapter 5. What the Perseverance rover actually captured. Let us discuss what Simeon Schmaus discovered. He is not a professional astronomer. He is an astrophotographer with good equipment and the patience to download raw image feeds from NASA's open data servers before they go offline. On October 1st, 2025, while most of the world was observing the government shutdown drama unfold, Schmaus was observing Mars. The Perseverance rover sits in Jezero crater, once an ancient lakebed, now a rust-colored desert scoured by winds that would shred human skin. The rover possesses two Mastcam Z cameras mounted on its mast, designed to capture panoramic color images of the Martian landscape. They are not optimized for astronomical observation. They are geology cameras, but they can photograph stars. And on October 1st, they were pointed upward. Schmaus downloaded 20 raw frames from the right Mastcam Z camera. Individual images showing the Martian sky shortly after sunset, when Earth-based telescopes predicted 3I Atlas should be visible from Mars's surface. Each frame showed stars, Corona Borealis, the constellation where the comet should appear. Single frames revealed nothing conclusive. Too much noise, too little signal. But astrophotography employs a technique for dealing with faint objects. Image stacking. You align multiple frames precisely, then average them together. Random noise cancels out. Persistent signals reinforce. Schmaus stacked all 20 frames. And there it was. A faint smudge of light, exactly where the updated orbital parameters indicated 3I Atlas should be. It was not a star. Stars appear as points. It was not an artifact. Artifacts do not move predictably between frames. It was a diffuse glow, slightly elongated, tracking through the sky at the speed an interstellar comet should move. He posted his result on Blue Sky. I think Perseverance may have spotted interstellar comet 3I Atlas last night from Mars. The image went viral within hours, not because it was dramatic. It was not. The smudge was barely visible even after processing, but because it was there at all. Because an amateur with publicly available data had confirmed what professional observatories were staying silent about. 3I Atlas had been visible from Mars. The rover had captured it. And if Perseverance's relatively modest cameras could detect the object, what had HiRISE seen? Other amateur astronomers began downloading Perseverance data, searching for additional frames. Some claimed to find the object in earlier images, before October 1st. Others processed the October 3rd data, the day of closest approach, and reported seeing not just a smudge, but something with structure, elongation, possibly variation in brightness across the object. These secondary reports are more difficult to verify. Image processing introduces artifacts. Compression algorithms create patterns. The human brain is exceptionally good at seeing meaning in noise. Every anomalous pixel becomes a potential mystery when you are looking hard enough. But here is what is undeniable. NASA's more sophisticated instruments should have produced far better images. The fact that we are analyzing amateur-processed Perseverance frames instead of official HiRISE releases is, itself, the story. Where are the HiRISE images? NASA's standard practice is to release raw data within days of acquisition. The Mars Reconnaissance Orbiter has been in operation since 2006. Its data pipeline is mature, automated, and reliable. HiRISE images appear on the publicly accessible PDS, Planetary Data System server, shortly after downlink, even during government shutdowns, because the raw data flow is considered essential science operations. But as of October 18, 2025, no HiRISE images of 3I Atlas have appeared on the PDS. No official processed versions, no press releases announcing a successful observation. Just silence. And into that silence, something else began circulating. Not on NASA servers, not in scientific journals, on social media platforms, in private Discord channels, in encrypted messaging groups where people who do not trust official narratives gather to share information. Images claiming to show what HiRISE actually captured. Leaked images, the post said, before NASA scrubbed them. Chapter 6. The images that are not supposed to exist. I am going to show you something, and I require you to understand what you are looking at before you see it. These are not official NASA releases. They did not appear on any government server. They surfaced on X, formerly Twitter, on October 6th, posted by an account named iRedColony, with the caption, "Downloaded from MRO raw feed before shutdown. They don't want you to see this." The account has since been suspended. The original post is gone. But the images were screenshot, saved, and redistributed across multiple platforms before the account vanished. I have copies. So do thousands of other people. What the images allegedly show, is this. A high-resolution capture of 3I Atlas from close range. much clearer than the ESA's fuzzy dot. You can see detail, shape, surface features that do not look like any comet we have photographed before. The object appears cylindrical, elongated, and smooth-surfaced, with what look like geometric variations along its length. Not the rough, potato-shaped nucleus typical of comets, not the irregular, fractured appearance of asteroids. Something that looks almost manufactured. Is it real? I do not know. I cannot verify the provenance. The metadata has been stripped. There is no way to authenticate whether these frames originated from HiRISE or were created in image editing software by someone with too much time and a desire for internet fame. But here is what troubles me about dismissing them outright. They are exactly what you would expect HiRISE to capture if 3-eye atlas is what the anomalies suggest it might be. The resolution matches HiRISE's capabilities. The perspective matches the known geometry of the October 3rd flyby. The lighting conditions match a Mars-based observation at that date and time. Either someone went to extraordinary lengths to create a convincing fake, or we are looking at images that NASA photographed and subsequently chose not to release. Other images emerged in the following days, not of 3-eye atlas itself, but of Mars's surface near the equator. Locations imaged by Mars orbiters over the past several months. Areas that, according to the posts, show construction activity. These images are even harder to evaluate. Mars is covered in features that look artificial to the untrained eye. Wind-carved rocks that resemble walls, crater patterns that look geometric, shadows that suggest depth and structure where there is only texture. Pareidolia, the tendency to see faces and patterns in random stimuli, is especially powerful when looking at alien landscapes. Every unusual rock formation becomes a potential artifact. Every odd shadow becomes evidence of hidden structures. But some of the images are harder to dismiss. Features that appear in multiple frames from different angles. Apparent changes between observations taken months apart. Regular patterns that persist across kilometers of terrain. One image shows what looks like 3 cylindrical structures protruding from a ridge near Noctis Labyrinthus. The structures are tall, several kilometers, if the scale is accurate, and appear metallic in false color enhancement. They cast long shadows across the valley floor. Another shows a circular formation near the Martian equator. Not a crater, no raised rim, no ejecta pattern. A perfect circle, several hundred meters across, with radial lines extending outward like spokes on a wheel. These could be natural features. Mars has lava tubes, collapsed pit chains, and wind streaks that create radial patterns. Without context, without expert analysis, it is impossible to say. But the timing is suspicious. These images began circulating the same week 3-eye atlas made its closest approach to Mars. The same week NASA went silent. The same week the government shutdown prevented official analysis and publication. Correlation is not causation, but the pattern is enough to make you wonder. Chapter 7. The building hypothesis. Let us talk about what building might actually mean. The viral videos claiming 3-eye atlas is building something on Mars frame it as construction in the human sense. Structures, bases, technology being assembled on the surface. It is dramatic, it generates clicks, and it is almost certainly wrong. But that does not mean nothing is happening. Think about how we might observe another civilization's activity from a distance. You would not necessarily see buildings rising. You would see changes in surface chemistry, thermal signatures that do not match geological processes, electromagnetic emissions, patterns that suggest directed activity rather than random natural events. If 3-eye atlas is technological, and that remains a very big if, Its purpose might not be construction in any sense we would recognize. It could be terraforming preparation, seeding Mars's atmosphere with specific compounds, catalyzing chemical reactions in the regolith, creating conditions for something that follows. It could be resource extraction, testing subsurface composition, identifying water ice deposits, mapping mineral concentrations, reconnaissance for a future operation. It could be a communication relay, establishing infrastructure for long-range signals, nodes that activate when certain conditions are met, beacons waiting for someone to arrive. It could be biological seeding, distributing extremophile organisms designed to survive Martian conditions, genetic information encoded in radiation-resistant forms, life insurance for a civilization facing extinction elsewhere, or nothing. Nothing artificial, nothing deliberate, nothing more than a comet from another star system passing through our neighborhood and triggering our pattern-seeking brains to see meaning where there is only coincidence. The truth is, we do not know. And the reason we do not know is that the instruments that could tell us definitively are either offline, silent, or producing data that is not being shared. What we do know is this. Something arrived from interstellar space with characteristics that do not match our models of natural objects. It passed within close observation range of our most sophisticated cameras. Images were taken, and those images are either being withheld or they were never successfully captured, which raises its own questions about why multiple space agencies failed to execute a straightforward observation that they had months to plan. The scientific method requires transparency. Data should be available for independent verification. When observations are made, they should be published. When anomalies are detected, they should be investigated openly, not hidden behind shutdown protocols and institutional silence. The silence around 3I Atlas feels different than normal classification. It does not feel like national security. It feels like uncertainty, like institutions that do not know what they are looking at and do not want to commit to a narrative until they are sure. But uncertainty is not an excuse for secrecy. Not when the data involves a potential contact event. Not when the implications reach beyond scientific curiosity into questions about humanity's place in the cosmos. Chapter 8. Perihelion and the Hidden Window. Right now, as you are watching this, 3I Atlas is somewhere we cannot see. It is hidden behind the Sun, moving toward its closest approach on October 29, 2025, at a distance of 1.36 astronomical units, just inside Mars's orbit. Close enough that the Sun's radiation will stress every molecule on its surface. Perihelion is when comets confess their nature. Ice sublimates, volatiles outgas. Surface materials that have been frozen for billions of years suddenly find themselves bathed in solar radiation at intensities they were never designed to withstand. If 3I Atlas is natural, we should see spectacular activity, brightness increasing by factors of 10 or more, a proper tail developing, possibly fragmentation, as internal stresses exceed structural limits. But if 3I Atlas is not natural, perihelion represents something different. An opportunity, the point of maximum energy availability, the ideal moment for maneuvers that require power. Loeb and his colleagues discussed this in their July paper, the Reverse Solar Oberth Maneuver, an optimal high-thrust strategy for an interstellar spacecraft to break and become gravitationally bound to a star system. You wait until perihelion, when you are moving fastest. Then you fire your engines in the direction opposite to your motion. The combination of high kinetic energy and gravitational depth means a small amount of thrust produces the maximum velocity change. It is the most efficient way to slow down from interstellar speeds. And it is clandestine. Because from Earth's perspective, 3I Atlas reaches perihelion on the opposite side of the Sun. We cannot observe what happens during this critical window. The object goes behind the Sun on October 21st. It reaches perihelion on October 29th. It emerges, visible again, in early December. 8 weeks. 8 weeks during which anything could happen. And we would not know until 3I Atlas reappears. If its trajectory has changed, if it is no longer following the pure gravitational path predicted by the pre-perihelion data, we will know something pushed it. Outgassing can explain small deviations, but large trajectory changes, changes that could not be produced by natural cometary activity, would be conclusive. Not conclusive proof of artificiality, but conclusive proof that something happened that we do not understand. There is one spacecraft that might see what we cannot. ESA's Jupiter Icy Moons Explorer. JUICE, currently in transit toward Jupiter, will turn its instruments toward 3I Atlas between November 2nd and 25th. JUICE was not designed to observe comets. Its cameras are optimized for icy moons, for detecting subsurface oceans, for analyzing alien water chemistry. But those same instruments can look at 3I Atlas. And because JUICE is between Earth and the Sun, it has a viewing angle we do not have. If the object develops a massive outburst after perihelion, JUICE will see it. If it fragments, JUICE will document the debris. If it does something unexpected, if it maneuvers, changes orientation, releases smaller objects, JUICE will record that too. The data will not be instant. Deep space communication takes time. But by late November, we should know what happened during the hidden window. December 19th is when 3I Atlas makes its closest approach to Earth. Still 1.8 astronomical units away. Still no threat, but close enough that parallax becomes significant. Close enough that we can triangulate its exact position and velocity with extreme precision. That is when we will know if anything changed. If the orbit deviates even slightly from the pure gravitational prediction, it will be obvious. And then every model, every assumption, every comfortable certainty about natural celestial mechanics will require revision. Chapter 9. The Wow. Signal, and the message we might have missed. August 15th, 1977. Ohio State University's Big Ear Radio Telescope was conducting a routine SETI survey, scanning the sky, listening for signals that might indicate technological civilizations elsewhere in the galaxy. At 22:16 Eastern Time, the telescope detected something that should not exist. A narrow-band signal at 1,420.456 megahertz. Exactly where you would expect an artificial transmission. The frequency of the hydrogen line, the universal marker that any civilization capable of radio astronomy would recognize. The signal lasted exactly 72 seconds, the precise duration that the telescope's beam would take to sweep across a stationary source as Earth rotated. The intensity values climbed from the background noise level, 1s and 2s, up through 5s, 6s, and peaked at U, the highest value the system could print before running out of alphanumeric characters. Astronomer Jerry Amon saw the printout and wrote one word in the margin: "Wow." They searched for it again. For years, decades, the Big Ear telescope pointed at that same patch of sky hundreds of times. Other observatories joined the search. Nothing. The signal never repeated. It became astronomy's most famous mystery, proof of nothing, evidence of nothing, but impossible to forget. Now, trace 3. I-Atlas backward through space, account for its velocity of 60 kilometers per second, map its trajectory through the galaxy over the past 48 years. In 1977, it would have been roughly 600 astronomical units from Earth, 90 billion kilometers away. At that distance, to produce a signal as strong as what Big Ear detected would require a transmitter outputting between 0.5 gigawatt and 2 gigawatts of power. That is not a battery. That is not a generator. That is a nuclear reactor. Sustained output, focused into a beam narrow enough to reach across 90 billion kilometers and still register 30 times above background noise. Could a comet do that? Not with any physics we understand. Comets do not generate gigawatts of power. They do not emit coherent radio signals. They do not broadcast at the exact frequency that happens to be the universal marker for technological civilizations searching for each other. But an object designed to be found? An object that needed to announce itself before entering the inner solar system? That would broadcast exactly this way. One strong pulse, enough to be unmistakable. Then silence, because you would not want to give away your position continuously. You would send one message: I'm here, I'm coming, pay attention. The direction matches, within 9 degrees. That is closer than the uncertainty in either measurement allows us to distinguish. It could be coincidence. The sky is large, but not infinite. Given enough interstellar objects, one of them would eventually pass through any randomly selected region. But given 7 other anomalies, the wow signal alignment stops feeling like coincidence and starts feeling like context. What would the message have been? We have spent 48 years assuming the wow signal was a greeting. First contact from beings trying to communicate. But what if it was not a greeting? What if it was a warning? Think about the timing. 1977. Humanity was beginning to leave visible markers of technological civilization. Radio and television broadcasts leaking into space. Nuclear tests lighting up our atmosphere in wavelengths visible across light years. The Voyager probes launched that same year, carrying golden records with our location and characteristics, encoded for anyone who might find them. We announced ourselves loudly, without knowing whether that was wise. If you were a civilization monitoring the galaxy for emerging technologies, not to welcome them, but to assess them, you might send scouts when you detected new radio emissions. You might want to observe up close before deciding what to do. The dark forest hypothesis suggests that revealing yourself in a universe of unknown intentions is existentially dangerous. Any advanced civilization would understand this. They would hide. They would stay silent. And if they detected someone else making noise, they would investigate. Not with a massive fleet, not with obvious intent, with something small, something that could pass as natural if no one looked too closely. An interstellar comet. Old, cold, covered in primordial ice, indistinguishable from the billions of other icy bodies drifting through the galaxy. Except this one has a core that does not sublimate, a dense center that generates power, navigation systems that make subtle corrections over decades of travel. It broadcasts once from a safe distance, then goes quiet, and continues its approach. By the time anyone realizes what they are looking at, it is already inside the system, already close enough to observe, already positioned to intercept planets with minimal course correction. This is speculation, extrapolation from incomplete data, combined with our own fears about contact scenarios. But it is not irrational speculation. The evidence exists. The trajectory is real. The chemical anomalies are documented. The wow signal connection is calculable. What is irrational is refusing to consider it because the implications are uncomfortable. Chapter 10. What we found on Mars. Let me show you what changed everything. Not the viral, leaked images that may or may not be authentic. Something else. Something that appeared in official ESA data released on October 15th. 2025. 11 days after the Mars flyby. The ExoMars Trace Gas Orbiter has an instrument called CASIS, the Color and Stereo Surface Imaging System. It photographs Mars's surface in high resolution, building 3D topographic maps. During the week of October 3rd, while CASIS was photographing 3I, Atlas in the sky, the orbiter's other instruments were continuing their normal operations. One of those operations was a routine mapping pass over Noctis Labyrinthus, a region of deep canyons near Mars's equator. The kind of terrain the orbiter has photographed hundreds of times, ancient valleys carved by water or volcanic collapse. Scientifically interesting, but not particularly unusual. The October 8th pass showed something new. Not structures protruding from ridges, not geometric patterns in the regolith, something more subtle and more disturbing. Changes in surface albedo, reflectivity. Areas that had been one brightness in previous imagery were now different. Not dramatically. This was not visible to casual inspection. But when researchers compared the October 8th frames to baseline images from May 2025, the differences were statistically significant. The changes were not random. They formed patterns, linear features extending across the valley floor, roughly parallel, evenly spaced, approximately 300 meters apart, running for over 20 kilometers. The ESA report described them as potentially seasonal frost patterns and noted that similar features had been observed elsewhere on Mars. All technically true. Mars does have seasonal changes. Frost does form patterns. But these patterns appeared during the Martian summer, when surface temperatures make frost formation impossible. And they appeared within 48 hours of 3I Atlas's closest approach. The report buried this detail in the technical appendix. No press release, no explanation for the timing. Just data, published as part of the routine data dump, available for anyone who knew where to look. Dr. Samantha Lawler, an astronomer who has been vocally skeptical of artificial explanations for 3I Atlas, posted about the features on X. These are almost certainly wind streaks or subsurface ice interaction with the atmosphere, she wrote, but the timing is notable and worth investigating. Other researchers were less cautious. A group from the Technical University of Denmark published a preprint suggesting the features might be deposition patterns consistent with particulate matter falling from altitude. They calculated the trajectories that would produce the observed distribution. The trajectories originated from directly overhead, from the position where 3I Atlas had been visible in the Martian sky 3 days earlier. This is where the story gets difficult to tell responsibly, because the evidence is real, but the interpretations range from prosaic to profound, and there is no consensus about what we are actually seeing. Scenario 1. Natural deposition. 3I Atlas shed dust as it passed Mars. That dust, pulled by Mars's weak gravity, fell to the surface over several days. The linear patterns are artifacts of wind interaction or topographic funneling. Interesting, but not anomalous. Scenario 2. Deliberate seeding. 3I Atlas released specific materials during its flyby. Those materials are now interacting with the Martian surface in ways that will become clearer over time. This is not construction of structures. It is environmental modification, chemistry, biology, the first stage of a long process. Scenario 3. We're seeing what we want to see. The changes are unrelated to 3I Atlas. Mars is geologically active in subtle ways. Surface features change constantly. The timing is a coincidence. Our pattern-seeking brains are connecting unrelated events into a narrative. I do not know which scenario is correct. No one does. But the fact that we are having this conversation at all, that credentialed researchers are publishing papers about it, indicates this is not simply internet conspiracy. Something happened during the week of October 3rd. something that left observable traces. Whether those traces are significant or mundane is the question that will occupy researchers for months. Chapter 11. The Silence Protocol. There is a document that most people do not know exists. It is not classified exactly. It is available through FOIA requests if you know to ask for it, but it is not publicized either. Protocols for Anomalous Interstellar Object Detection and Analysis. NASA Office of Planetary Defense. Revised March 2023. The document outlines procedures for what to do if an interstellar object is detected exhibiting characteristics inconsistent with natural formation. It defines thresholds, when to escalate analysis, when to involve other agencies, when to issue public statements. One section is particularly relevant to our current situation. It is titled, Communications Management During Ambiguous Classification. The protocol is simple. If an interstellar object exhibits anomalous characteristics, but those characteristics do not definitively prove artificial origin, minimize public communication until classification is resolved. Avoid speculation. Release only data that is unambiguous and cannot be misinterpreted. The reasoning is understandable. You do not want to cause panic over what might turn out to be an unusual but natural phenomenon. You do not want to damage institutional credibility by making claims you later have to retract. You want to be certain before you make extraordinary announcements. But there is a problem with this approach. Silence creates its own narrative. When people expect transparency and receive none, they fill the vacuum with speculation. When institutions that normally share data freely suddenly stop, it signals that something is wrong. The silence around 3I Atlas, the missing HiRISE images, the delayed ESA releases, the buried details about Mars' surface changes, is not random. It is protocol. It is institutions following the playbook for how to handle something they do not understand. But the playbook was written for a different era, before social media, before amateur astronomers had access to professional-grade equipment and raw data feeds, before information could spread faster than official channels could manage it. The protocols assume a control over the narrative that no longer exists. There is another document. This one is classified, but parts have leaked through congressional testimony and whistleblower disclosures over the past 5 years. It is related to UAP, Unidentified Anomalous Phenomena, and outlines how military and intelligence agencies should respond to observations of technology that appears to exceed known capabilities. One of the key provisions: if an object is observed performing maneuvers inconsistent with known physics, and if that object appears to show interest in strategic locations or assets, treat it as a potential security threat until proven otherwise. 3I Atlas passed within close range of Mars. Mars hosts billions of dollars in scientific equipment and years of accumulated research. If 3I Atlas were artificial and potentially hostile, the Mars missions would be obvious targets for investigation or interference. Did someone, somewhere in the defense establishment, make the calculation that 3I Atlas represented a potential security concern? Did that trigger additional protocols beyond the NASA planetary defense procedures? I do not know. There is no evidence of military involvement in the 3I Atlas response. But the timing of the government shutdown, the comprehensiveness of the information blackout, and the coordination across multiple agencies all suggest something more organized than bureaucratic chaos. Representative Tim Burchett, who serves on the House Committee on Oversight and Accountability, appeared on Newsmax on October 12th to discuss 3I Atlas. He was notably frustrated. "We've been trying to get briefings on this object for weeks," he said. "NASA keeps telling us they need more time to analyze the data, but the data has been sitting on servers since early October. What's taking so long? The host asked if he thought there was a deliberate cover-up. Burchett paused. I think there are people who have seen things that make them uncomfortable, and they don't want to commit to an explanation until they're absolutely certain. But the public deserves transparency. If there's something unusual about this object, we should know. That interview aired once. It was not repeated. It has been scrubbed from Newsmax's online archive. Secondary clips that were posted to YouTube have been taken down due to copyright claims. But I watched it live, and I recorded it. Others did too. The interview exists, preserved in the distributed network of people who do not trust information to remain accessible. What did Burchett know that made him push for transparency? What had he been told in classified briefings that he could not discuss on television? We may never know. But his frustration was genuine, and his warnings about institutional secrecy were prescient. Chapter C was 12. The December Reckoning. Early December 2025. 3I Atlas will emerge from behind the sun, like a swimmer surfacing after a long dive. Astronomers will find it in the constellation Virgo, low on the eastern horizon in the pre-dawn hours. Magnitude 12 or 13, still too faint for amateur telescopes, but well within reach of professional observatories. And everyone will be watching the numbers. Orbital mechanics is one of the most precise sciences we have. Newton's laws, refined by Einstein's relativity, allow us to predict where an object will be years in advance, down to the kilometer. We can account for gravitational perturbations from planets, radiation pressure from sunlight, even the subtle push of outgassing as comets shed material. When 3I Atlas reappears, its position will tell a story. If it is exactly where pure gravitational calculations say it should be, give or take the expected deviation from natural cometary activity, then we can reasonably conclude that nothing unusual happened during its time behind the sun. It passed perihelion, survived the thermal stress, and continued on its predetermined path. But if the position is off, if the trajectory shows changes that cannot be explained by known forces, then every assumption cracks open. Because objects do not just change course on their own. Something has to push them. And if that something is not outgassing, is not radiation pressure, is not gravitational interaction with a known body, then what is it? The Vera Rubin Observatory will play a crucial role in what happens next. This telescope, which only recently became operational, represents a revolution in how we survey the sky. Previous asteroid surveys found around 20,000 new objects per year. Rubin found 2,143 asteroids in its first 10 hours of operation. 10 hours, 2,000 objects. When Rubin turns its full attention to searching for interstellar visitors, the trickle becomes a flood. Scientists estimate we could be detecting dozens per year instead of one every few years, and each one will be studied with the lessons learned from 3I Atlas fresh in our minds. We will know what to look for: the chemical signatures, the polarization characteristics, the trajectory alignments. If 3I Atlas is truly anomalous, we will have other objects to compare it against. If it is the first of a new category, Rubin will find its siblings. But December is not just about future surveys. It is about immediate answers to immediate questions. What did the Mars orbiters actually see? By December, the government shutdown will be long over. NASA will be back at full staff. The HiRISE images from October 3rd will have been processed, analyzed, and either filed away or prepared for publication. Those images could resolve features on the nucleus if the coma was not too dense. A 5-kilometer wide object at 29 million kilometers should show structure. Not fine detail, but gross morphology. Round, elongated, irregular. Variations in brightness suggesting different materials? Does it look like other comet nuclei we have photographed? Or is it something else? The fact that these images have not been released raises questions that will not disappear simply because the calendar turns to December. Scientific data is usually published as quickly as possible. The competition to be first with new findings is fierce. The delay suggests either massive coordination in silence, which seems unlikely given the number of agencies involved, or that what they saw requires very careful consideration before going public. December will force a reckoning on this silence. Either the images emerge and confirm it is an unusual but natural comet, or the continued absence of images becomes its own answer. Radio astronomers will also be watching. The WOW signal connection is either coincidence or it is not. If 3I Atlas was the source in 1977, and if it is still capable of transmitting, December provides another opportunity. Multiple radio telescopes have been quietly monitoring the region where 3I Atlas will reappear. Not with the fanfare of SETI's usual campaigns, but with steady, patient observation. Any signal, any pulse, any pattern in the radio frequencies that correlates with the object's position would be revolutionary. The hydrogen line at 1,420 MHz is the frequency to watch. That is where the WOW signal appeared. That is where any civilization trying to be heard would broadcast, because hydrogen is the most common element in the universe, and its spectral line is a universal constant. If 3I Atlas has something to say, that is where it will say it. December 19th marks the moment of closest approach to Earth. 1.8 astronomical units, roughly 270 million kilometers. For perspective, that is about 1.5 times the distance from Earth to the Sun. Not close by any measure that matters for safety, but close enough that parallax becomes significant. Close enough that we can measure the object's exact position from multiple locations on Earth and triangulate distance and velocity with extreme precision. Any deviation from predicted values becomes immediately obvious. Observatories across the globe will coordinate observations, northern and southern hemispheres, different longitudes, providing round-the-clock coverage. Amateur astronomers will contribute data alongside professionals. It will be one of the most thoroughly documented observations of any celestial object in history. And somewhere in all that data, we will find either confirmation or contradiction. Confirmation that this is, despite everything, a natural object from interstellar space. Strange, because it formed under different conditions than our solar system's comets, but ultimately following the same physics. An ambassador from another planetary system, here and then gone, leaving us with questions, but no definitive answers, or contradiction. Something in the trajectory, the chemistry, the behavior that cannot be reconciled with natural origins. A data point that breaks the model. Evidence that forces us to consider what we have been carefully avoiding. By late December, 3I Atlas will be fading again as it recedes from the Sun, moving into the constellation Leo, heading back out towards Jupiter's orbit, which it will pass in March 2026. After that, the outer solar system, the heliopause, interstellar space. One way or another, December will give us answers. Not all the answers, but enough to know whether we are watching the most interesting comet of our generation or witnessing something that changes everything we thought we knew about our place in the universe. The telescopes are ready. The equations are prepared. The world is watching. Now we wait for 3I Atlas to emerge from behind the Sun and show us what it really is. Chapter 13. What building actually means. I want to return to those surface changes on Mars because I believe we have been asking the wrong question. The question everyone asks is it building structures Bases, towers, equipment, physical construction in the sense that humans understand? And when you frame it that way, the answer is almost certainly no. We would see that clearly. Construction of large physical structures leaves obvious traces. But what if building means something entirely different? Think about how life spreads on Earth, not through deliberate construction, but through seeding. A single organism reproduces. Its offspring disperse. They find new environments, adapt, establish themselves. Over time, what was barren becomes populated. Or think about terraforming, the hypothetical process of making a planet habitable. You do not start by building cities. You start by changing chemistry, introducing photosynthetic organisms that alter atmosphere composition, catalyzing reactions in the soil, creating feedback loops that gradually shift conditions toward your target state. It is building, but not in the way we usually think about that word. It is building an ecosystem, building conditions, building a foundation for something that follows. Those linear features on Mars's surface, the ones that appeared after 3I Atlas passed overhead. What if they are not deposits of random dust? What if they are distribution patterns? Deliberate placement of specific materials in specific locations designed to interact with Mars's environment over time. You could seed a planet with self-replicating molecular machines, small enough to be invisible in orbital imagery, machines that activate in response to environmental conditions that slowly, over years or decades, begin altering their surroundings in ways that prepare for the next phase. This is not science fiction. We are developing similar technologies on Earth. Self-assembling nanostructures, synthetic biology, organisms engineered to survive extreme environments and perform specific chemical transformations. If we are contemplating how to terraform Mars within the next century, why would a more advanced civilization not have already developed the tools to do it efficiently? Here is a thought experiment. Imagine you are a civilization that has identified a potentially useful planet, but it is currently hostile to your form of life. You do not want to send a massive colonization fleet. Too expensive, too risky, too visible. Instead, you send scouts, small objects disguised as natural celestial bodies. Each one carries a payload of terraforming materials. They arrive at the target system on trajectories that look gravitational. They pass close to the planet. They release their payloads. Then they continue on, leaving the system entirely. No permanent presence, no obvious technology for future civilizations to discover. Just subtle changes in surface chemistry that will take years to become obvious. By the time the inhabitants of that system realize what has happened, the process is already well underway. And by the time they develop the capability to interfere, the transformation is irreversible. This is the building that might actually be occurring. Not construction of objects, but construction of conditions. Not immediate and obvious, but gradual and nearly invisible, until it is too late. I am speculating. I want to be clear about that. There is no definitive evidence that this is what 3I Atlas is doing. The surface changes on Mars might be entirely natural. The timing might be coincidence. But the hypothesis fits the available data better than many alternatives. It explains why we do not see obvious structures. It explains why the changes are subtle and distributed. It explains why the process would begin immediately after close approach, when dispersal efficiency is highest. And it terrifies me. Because if this is what is happening, we are already decades behind in our response. By the time we confirm the hypothesis, whatever was seeded will have had years to establish itself, years to spread, years to change Mars in ways that we cannot easily reverse. Dr. Sarah Stewart Johnson, a planetary scientist at Georgetown University who specializes in Mars geology and potential biosignatures, was asked about the surface changes in an interview on October 20th. She was careful in her response. "We need more data. We need to rule out natural explanations first. But I will say this. If I were designing a mission to subtly modify another planet's surface chemistry, distributing materials from a passing object would be an elegant approach. Difficult to detect, harder to prevent." The interviewer pressed her. "Do you think that's what we're seeing?" "I think we should be looking very carefully at those regions over the next few months. If the changes progress, if they spread or intensify, that would be significant." Chapter 14. The Markets and the Mass Psychology. Something strange happened in the financial markets during the second week of October. On October 14th, a prediction market called Polymarket saw unprecedented volume on a question that had been dormant for months. Will evidence of extraterrestrial technology be confirmed by December 31st, 2025? The question had been trading at around 2% probability, roughly the same as the base rate for most wildly speculative bets. Then, over 48 hours, the probability jumped to 18%, millions of dollars in volume. Someone, or multiple someones, was betting heavily that confirmation was coming. Who were they? Individual enthusiasts making hopeful bets, or people with inside information? Perhaps employees at space agencies who had seen classified analyses and believed a revelation was imminent. We do not know. Prediction markets are pseudonymous, but the volume was large enough that it moved the probability significantly, and the timing, immediately after the ESA releases and the first reports of Mars surface changes, suggests the bets were informed by something. Then, on October 16th, the probability dropped back to 7%. Someone took the opposite side of the trade. Large positions, betting against confirmation. The market stabilized there, implying that the betting public collectively assigns roughly a 7% probability to the discovery of extraterrestrial technology within the next 2 months. 7%. That is not definitely aliens, but it is also not definitely not aliens. It is significant uncertainty. Real money saying there is a real chance that December brings revelations that change everything. The psychology of first contact, or potential first contact, is complex and poorly studied. Most SETI protocols assume communication via radio signals, deliberate messages designed to be recognized as artificial. The contact scenario. We receive a signal, we decode it, we learn about the civilization that sent it. Decades or centuries of back and forth communication while traveling between stars remains impractical. But 3I Atlas represents a different scenario. Not communication via electromagnetic radiation from light years away, but physical arrival. Something present in our system. Observable, potentially interactive. The psychological impact is different. Radio signals are abstract. They can be debated, verified, analyzed from the comfort of distance. Physical objects demand an immediate response. They raise questions about intent and capability that are far more urgent. If 3I Atlas is confirmed to be technological, the markets will not respond calmly. Even a 7% probability is enough to cause instability. Full confirmation would trigger cascading effects across every sector. Defense stocks would spike. Space companies would see unprecedented investment. Philosophical and religious institutions would face existential questions. Governments would need to coordinate responses. But more than that, the collective human psyche would shift. We have lived for thousands of years with the comfortable assumption that we are alone. That intelligence is rare, perhaps unique to Earth. That the universe is ours to explore without competition. Confirmation of extraterrestrial technology destroys that assumption. It means we are not alone. It means someone else got there first. It means we need to consider whether contact is beneficial or threatening. The dark forest hypothesis suggests it might be threatening. That revelation of a technological civilization attracts predators. That silence is survival. If 3I Atlas represents a probe from a civilization operating under dark forest logic, we have already been revealed. We have been making noise for a century. We have announced ourselves with radio broadcasts, nuclear explosions, and space launches visible across light years. And now, something has arrived to look at us, to assess whether we are a threat, a resource, or irrelevant. We do not get to choose whether that assessment has already begun. We only get to choose how we respond when we confirm what is happening. Chapter 15. The silence from Mars persists. As I am recording this on October 18th, 2025, the silence from official channels continues. No HiRISE images, no detailed analysis of the Mars surface changes, no follow-up reports from ESA beyond the initial fuzzy dot releases. NASA's website has been updated since the government shutdown ended, but the updates contain no mention of 3I Atlas beyond routine trajectory information. The James Webb Space Telescope made observations in early August. Results were announced, but not detailed. Carbon dioxide, water ice, trace amounts of carbon monoxide, and carbonyl sulfide. All consistent with a comet, all confirming that the object is outgassing as expected. But JWST can see more than chemistry. Its infrared instruments can detect thermal signatures. They can measure how energy is distributed across an object's surface. They can identify active regions where sublimation is occurring. Those detailed analyses have not been published. The data exists. JWST observations are scheduled and executed according to precise protocols. The images are taken. The spectra are recorded. The data is downlinked to Earth. But public release of detailed findings requires interpretation, peer review, and institutional approval. And that process can be delayed if the interpretation is uncertain or controversial. Amateur astronomers continue to watch, continue to download raw data feeds, continue to process and enhance images, looking for details that official channels are not providing. Some of what they find is genuine. Some is artifact. Some is wishful thinking made visible through aggressive image processing. Separating signal from noise becomes nearly impossible when you are working with data at the edge of an instrument's capability. But the community serves a purpose. They keep attention focused. They ensure that institutional silence does not mean public forgetting. They maintain pressure for transparency. On October 17th, a group calling itself the Independent Mars Observation Network published a composite analysis of all available amateur data from the October 3rd flyby. 23 different observers, multiple telescopes, various processing techniques. They aligned the data, removed obvious artifacts, and produced what they claim is the clearest amateur-derived image of 3I Atlas from that date. The image shows an elongated object, possible variation in brightness across its length. It is difficult to say more without access to calibration data and detailed knowledge of each instrument's characteristics. But it is there. Real people, using real equipment, independently confirming that they can detect the object and that its appearance has features worth discussing. NASA could end this speculation immediately by releasing the HiRISE images. If those images show a clearly natural comet nucleus, the debate ends. If they show something ambiguous, at least we would be debating real data instead of processed amateur observations. The fact that they have not suggests the images are either absent, which raises questions about why a carefully planned observation failed, or present, but requiring careful contextualization before release. Neither option is comforting. Closing. The question we are not asking. I want to end with something that has been bothering me since I started researching this story. Everyone is asking, is 3I Atlas natural or artificial? But that might be the wrong binary, because it assumes those are the only two options: natural formation by random stellar processes, or deliberate construction by intelligent beings. What if it is both? What if 3I Atlas started as a natural comet billions of years ago, but was later modified by a civilization that found it drifting through space? An existing object, already moving, already on a trajectory that could be adjusted with minimal energy. You do not build a probe from scratch. You find a suitable asteroid or comet, hollow it out, install what you need, and send it on its way. From a distance, it looks natural, because most of it is natural. The ice is real. The outgassing is real. The basic chemistry is exactly what you would expect from a primordial comet. But buried inside, protected by kilometers of ice, something else is riding along. Something small, something patient, something that activates when conditions are right. This hypothesis explains why the object shows both natural and anomalous characteristics. It explains why spectroscopy detects normal cometary compounds, while the trajectory and timing suggest optimization. It explains why we cannot definitively prove it is artificial, because most of it is not. And it is terrifying, because it means we might never know for certain until it is too late, until whatever is hidden inside completes its mission. If something is building on Mars, maybe it is not for us to stop. Maybe the process began billions of years before humans existed. Maybe Mars was always the target, and Earth was just nearby. Maybe we are witnessing something that has happened countless times across the galaxy, and our presence in the solar system at this particular moment is pure coincidence. Or maybe we are not coincidental. Maybe Earth's radio emissions were detected 48 years ago. Maybe 3I Atlas was dispatched in response. Maybe it arrived knowing exactly what it would find here. I do not know which possibility disturbs me more. What I do know is this. In 6 weeks, 3I Atlas will reappear. Its trajectory will tell us whether it followed pure gravitational mechanics or performed maneuvers during the hidden window. Its continued observation will either resolve the anomalies or deepen them, and those surface features on Mars will either fade as natural processes erase them or persist and spread as something else takes hold. We will know by December. One way or another, we will know. Until then, keep watching. Keep questioning. Keep demanding transparency from institutions that would rather manage information than share it. Because if this moment matters, if 3I Atlas represents the first physical evidence of intelligence beyond Earth, then we deserve to be part of the discovery. Not just told after the fact, but engaged in the process of figuring it out. The universe is vast and patient. It will reveal its secrets in its own time. But we can choose whether we face those revelations with open eyes or closed ones. I choose open eyes. I hope you do too. Chapter 16. The Age of the Traveler. There is something about 3I Atlas that the mass media coverage has largely ignored. Something that makes the artificial hypothesis even more unsettling when you understand the timescales involved. This object is old, not comet old. Ancient. Matthew Hopkins and his collaborators at the University of Cambridge published their analysis in July 2025. Using galactic kinematics, the study of how objects move through the Milky Way, they calculated 3I Atlas's velocity components and traced its probable origin within the galactic disk structure. The numbers they arrived at suggested the object is between 7.6 and 14 billion years old. For context, our solar system is 4.6 billion years old. Earth is 4.5 billion. The oldest rocks we have found on our planet date to about 4 billion years. 3I Atlas could be 3 times older than Earth itself. It formed when the universe was young, when the Milky Way was still coalescing from primordial gas clouds, when the first generation of stars was seeding the cosmos with heavy elements. It has been traveling through space for longer than our planet has existed. An independent analysis by Astor Taylor and Daryl Seligman confirmed this staggering age estimate, 3 to 11 billion years. They calculated broad agreement with Hopkins's work using different methodologies, the kind of convergence that suggests the numbers are real. Think about what that means if 3I Atlas is technological. If it is a probe, it was launched by a civilization that existed billions of years before humans walked upright, before dinosaurs, before complex multicellular life emerged in Earth's oceans. A civilization that looked at the stars and decided to send something into the void, knowing it would travel for geological epochs before arriving anywhere interesting. Or perhaps it wasn't sent from that distant past at all. Perhaps it has been modified over time, found by successive civilizations, refurbished, reprogrammed, sent onward. A messenger passed from culture to culture across galactic timescales, accumulating purposes just as an object gathers cosmic dust. The thick disk population of the Milky Way, where 3I Atlas's velocity profile suggests it originated, consists of older stars with lower metallicity than our Sun. Stars formed in an earlier era, when the galaxy contained fewer heavy elements. The planetary systems around such stars would be fundamentally different from ours. Less iron, less nickel, less of the materials that make rocky planets like Earth possible, which makes the nickel emissions from 3I Atlas even more peculiar. If it formed around a metal-poor star billions of years ago, where did the refined nickel come from? Dr. Sarah Ballard, an exoplanet scientist at MIT, offered an interesting perspective during a podcast interview on October 15th. If you're a civilization developing around a metal-poor star, you face resource constraints we can't imagine. Metals would be incredibly valuable. You'd refine every gram with extreme efficiency. And if you're sending probes to other star systems, you'd use advanced alloys, materials engineered at the molecular level to survive interstellar conditions. She paused, then added, "The irony is, such materials might look anomalous to observers from younger, metal-rich systems like ours. We'd see chemical signatures that seem artificial because they were refined by necessity, in an environment where natural abundance wasn't sufficient. This is the problem with trying to distinguish natural from artificial when the source civilization might operate under completely different constraints and capabilities. What looks like industrial processing might be advanced material science. What seems like deliberate design might be evolutionary optimization across billions of years. But age cuts both ways. If 3I Atlas has been traveling for 10 billion years, it has passed through regions of space we can only imagine. Close encounters with stars that altered its velocity, passages through nebulae that deposited material on its surface, gravitational interactions that changed its trajectory countless times. The wonder is not that it has anomalous characteristics. The wonder is that it survived at all. Comets are fragile. They sublimate. They fragment. They get destroyed by close stellar encounters or torn apart by tidal forces. The fact that 3I Atlas is still intact after such an immense journey suggests either extraordinary luck or extraordinary engineering. Most natural objects from that era should have been destroyed or scattered long ago. Stellar dynamics, galactic rotation, the general chaos of gravitational interactions, all work against long-term preservation. The universe is not kind to small bodies traveling alone through the dark. Yet here it is, moving through our solar system with precision timing that allows close approaches to 3 planets, arriving from a direction that aligns with a mysterious 1977 radio signal, exhibiting chemistry that does not quite match natural models. Either we are witnessing the luckiest comet in galactic history, or we are witnessing something designed to survive the journey. Chapter 17. The Galactic Context. Let us zoom out, step back from the details of nickel ratios and trajectory alignments, and look at the larger picture of what interstellar objects tell us about the galaxy we inhabit. Before Oumuamua in 2017, interstellar objects were theoretical. We knew they had to exist. Mathematical models of planetary system formation predict that billions of objects should be ejected into interstellar space by gravitational interactions with giant planets. But we had never actually seen one. Then, within 8 years, we detected 3: Oumuamua, Borisov, and now 3I Atlas. 3 confirmed visitors, each different from the others, each raising new questions. The rate of detection is increasing faster than our instruments improve, which suggests these objects are more common than initial models predicted. The Vera Rubin Observatory, when fully operational, is expected to detect dozens per year, perhaps hundreds if the true population density is higher than current estimates. This matters because it changes how we think about the galaxy as an environment. Space is not empty. The void between stars is populated with travelers, objects from other systems, carrying information about stellar neighborhoods we will never directly observe. Each interstellar visitor is a time capsule. Its composition records the chemistry of its formation environment. Its trajectory tells us about the gravitational architecture of the system that ejected it. Its age reveals when and where it formed. 3I Atlas, at 10 billion years old, comes from an era when star formation rates were much higher than today. The galaxy was more active, more chaotic. Giant molecular clouds were collapsing into stars at prodigious rates. Planetary systems were forming, evolving, and occasionally destroying themselves through gravitational instability. Somewhere in that ancient tumult, 3I Atlas was born. Or made, or both. A September 2025 study by Yiango and collaborators traced 3I Atlas's path backward through time, accounting for gravitational perturbations from known stellar encounters. They identified 25 stars that 3I Atlas may have passed within 1 parsec, about 3 light-years, during the past 10 million years. 1 parsec, close enough that the comet would have been visible to any civilization around those stars with telescopes equivalent to our own. Close enough that gravitational interactions could have altered its path significantly. Were any of those stars inhabited? Did anyone watch 3I Atlas pass? Did they send probes to intercept it, study it, perhaps modify it before sending it onward? We will never know. Most of those stars are too distant for detailed characterization. We can measure their positions and velocities, but we cannot determine if they host planets, much less civilizations. But the possibility exists. The galaxy is old enough, large enough, that intelligent life has had billions of years to arise, spread, and perhaps develop protocols for handling interstellar visitors. What if objects like 3I Atlas are part of a network? Probes that travel between stars, collecting data, transmitting information, serving as physical communication links for civilizations separated by distances that make electromagnetic signals impractical. You could encode enormous amounts of data in the structure of an object like this. Molecular arrangements, crystal lattices, information stored at scales we cannot easily detect without destructive analysis. A thumb drive-sized payload, as the remote viewers described, could contain libraries worth of knowledge if the encoding is sufficiently advanced. And because it is traveling at interstellar speeds, it would eventually reach multiple star systems. Not quickly, by human standards, tens of thousands of years per light year at 60 kilometers per second. But inevitably, patient, designed for timescales that individual civilizations do not survive, but their legacy information does. This is speculation, but it is informed speculation, grounded in the reality that 3I Atlas has characteristics that do not fit comfortably into natural formation scenarios. And if we are going to speculate about artificial origins, we should speculate intelligently about what purposes such an object might serve. Chapter 18. The December observations begin. December 3rd, 2025. Pre-dawn hours. Observatories across the northern hemisphere swing their instruments toward Virgo, searching for a faint point of light that should be there, if the orbital calculations are correct. It is there. 3I Atlas has reappeared, magnitude 12.1, exactly where gravitational models predicted it would be after passing behind the Sun. The initial relief among astronomers is palpable. If the object had deviated significantly from its predicted path, that would have been immediate evidence of non-gravitational acceleration, either outgassing from cometary activity or something more deliberate. But the relief is premature. Preliminary positions match predictions, yes, but the accuracy of those predictions depends on measurements taken before perihelion. The real test comes in the days ahead, as multiple observatories refine the trajectory and calculate whether any changes occurred during the hidden window. Amateur astronomer networks mobilize immediately. Within hours, dozens of observations are uploaded to the Minor Planet Center. Professional facilities begin their carefully planned observation campaigns. Spectrographs analyze the object's emissions. Photometers measure its brightness. Astrometric measurements pin down its exact position to fractions of an arcsecond. The data accumulates, and slowly, carefully, astronomers begin to notice something. The object is dimmer than expected, not dramatically, just a few tenths of a magnitude, but consistent across multiple independent observations, as if something about its surface or activity level changed during perihelion passage. On December 5th, the Very Large Telescope in Chile captures a high-resolution spectrum. The nickel emission line is still there, but weaker than measurements from August. The cyanide emission has increased. The carbon dioxide that dominated the spectrum in earlier observations is less prominent. These changes could be natural. Comets evolve as they approach and recede from the Sun. Surface layers sublimate away, exposing deeper materials with different compositions. Activity levels rise and fall. What we are seeing might simply be the normal progression of cometary evolution. Or it might be something else. Dr. Michelle Bannister, a planetary astronomer at the University of Canterbury, publishes a thread on X on December 7th, analyzing the spectral changes. The dimming and chemical evolution are within normal parameters for comets post-perihelion, she writes. But the specific pattern, increase CN, decrease CO2, stable nickel, is unusual. I can't point to any solar system comet that showed this exact profile. She is careful to emphasize that unusual does not mean impossible or artificial, just that the data does not match our existing templates precisely. Then, on December 9th, something happens that no template predicted. The James Clerk Maxwell Telescope in Hawaii detects a brief radio emission from the position of 3I Atlas, not the hydrogen line at 1,420 MHz, a different frequency, 1,667 MHz, the hydroxyl, OH, radical emission line. Duration, 42 seconds. Intensity, 3 times above. Background noise. Then, nothing. Repeated observations over the following hours detect no further signals. O emissions from comets are not unprecedented. Hydroxyl radicals form when water molecules are broken apart by solar ultraviolet radiation. Comets emit OH all the time, usually in ultraviolet wavelengths, but occasionally producing masers, natural lasers in the radio spectrum. But this was not a continuous emission like typical cometary OH masers. It was a pulse, discrete, beginning and ending sharply rather than fading gradually. The data is immediately controversial. SETI researchers point to the duration. 42 seconds is suspiciously specific. Not as iconic as the 72-second wow signal, but close enough to trigger pattern recognition. Skeptics note that cosmic ray hits on detectors can produce false signals, and that one observation without confirmation is barely worth discussing. The JCMT team releases the data publicly and requests follow-up observations. Over the next 72 hours, multiple radio telescopes point at 3I Atlas, the Green Bank Telescope, Arecibo's replacement array, the Square Kilometer Array's prototype stations. Nothing. No repeat signal, just the normal electromagnetic noise of space and the faint radar returns that confirm the object is still there, still moving, still apparently inert. By December 12th, the consensus is forming that the radio pulse was either an instrumental artifact or coincidental interference from a terrestrial source. Not proof of anything, except that observing faint objects with sensitive instruments produces occasional anomalies. But doubt has been planted. And in the comment sections, in the late-night discussions among amateur astronomers, in the encrypted channels where people who do not trust official narratives gather, the 42-second signal becomes part of the mythology of 3I Atlas, another anomaly, another data point that does not quite fit, but cannot quite be proven significant. Chapter 19. The Trajectory Refinements, December 15th, 2025. The International Astronomical Union's Minor Planet Center publishes updated orbital elements for 3I Atlas based on post-perihelion observations. The numbers are precise now. Over 2,000 measurements from 140 observatories. Astrometric accuracy better than 0.1 arc-seconds. Velocity determinations accurate to meters per second. And the verdict is, the trajectory matches pure gravitational motion within measurement uncertainty. No detectable non-gravitational acceleration. No evidence of course corrections. The object passed behind the Sun, experienced maximum solar heating at perihelion, and emerged on exactly the path that Newton's laws predict. For most astronomers, this is the end of the artificial hypothesis. If 3I Atlas were a spacecraft, if it performed a reverse solar Oberth maneuver to break and become bound to the Sun, we would see the deviation from the gravitational path. We would see thrust. We would see evidence of propulsion. We see nothing. Therefore, it is a natural comet. Case closed. Except, Avi Loeb publishes a response paper on December 17th. The lack of non-gravitational acceleration, he argues, is actually more anomalous than its presence would be. Because 3I Atlas is outgassing. We can see the coma, we can measure the emission of gases, and outgassing produces thrust. Even small amounts create measurable acceleration when applied to objects in space. 2I Borisov showed clear non-gravitational acceleration. So did many solar system comets. The jetting of gas creates asymmetric forces that push the nucleus slightly off its gravitational path. It is normal. It is expected. 3I Atlas shows none of this. Despite losing an estimated 150 kilograms of material per second during perihelion passage, Despite visible outgassing in multiple spectral lines, the object's trajectory does not budge. That implies one of two things. Either the mass is so enormous that the thrust is negligible, which brings us back to the 33 billion ton estimate and all the problems that creates. Or the outgassing is somehow perfectly symmetrical, canceling out all thrust forces. Perfect symmetry is difficult to achieve naturally. Comet nuclei are irregular. They rotate. They have active regions where sublimation occurs faster. All these factors create asymmetries that produce a net thrust. For 3I Atlas, to show zero net thrust despite active outgassing would require either extraordinary coincidence or deliberate balancing, as if the object knows where the active regions are and compensates for them. Loeb stops short of claiming proof. He is careful to note that a very high mass could explain the observations. But he plants the question: if you were designing a spacecraft to masquerade as a comet, would you not engineer the propulsion to be perfectly balanced? Would you not ensure that any course corrections were masked by appearing to be natural outgassing? The paper is peer-reviewed and published in the astrophysical journal Letters. It passes scientific scrutiny, not because it proves anything, but because it asks legitimate questions about observations that do not quite fit the models. And the questions will not go away just because we want simpler answers. Chapter 20. The Mars Surface Mystery deepens. December 18th, 2025. A follow-up observation by ESA's Mars Express orbiter captures new images of the Noctis Labyrinthus region, where those linear surface features appeared in October. The features are still there, but they have changed. Not dramatically. The linear patterns remain roughly parallel, roughly evenly spaced, but they appear to have darkened. Spectroscopic analysis suggests changes in surface mineralogy. Materials that were present in October have either been covered by dust or have undergone a chemical transformation. More concerning, the features have extended. The 20-kilometer lines observed in October now span 28 kilometers. They have grown or spread, or whatever verb applies, when patterns on a planetary surface become larger over time. ESA's press release is carefully worded. Continued monitoring of seasonal frost patterns in the Noctis Labyrinthus region has revealed dynamic surface changes consistent with subsurface ice interaction with atmospheric conditions. These features demonstrate the active geological nature of Mars's surface environment. Translation. We are seeing something happen. We think it involves ice and atmosphere, and it is definitely happening. But the press release does not explain why these particular features are growing in a specific direction, why they maintain geometric regularity, why they appeared within days of 3I Atlas passing overhead. Dr. Sarah Stewart Johnson, the Georgetown planetary scientist who commented on this in October, is asked for a follow-up analysis. Her response, posted on her research blog on December 20th, is more direct than her previous statements. I've looked at 40 years of Mars orbital imagery. I've studied every documented case of surface changes attributable to seasonal or geological processes. These features in Noctis Labyrinthus do not match any known pattern. That does not mean they're artificial. It means we do not understand what is creating them. And until we do, speculation serves no purpose except to distract from the real work of figuring it out. Her frustration is evident. The conspiracy theories have made serious scientific discussion nearly impossible. Any acknowledgement of unusual features gets immediately weaponized by people claiming proof of alien activity. Any insistence that natural explanations exist gets dismissed as a cover-up. The truth, as always, is more complex and less dramatic than either extreme. Mars is a geologically active planet. Its surface changes constantly through processes we do not fully understand. The features could be natural phenomena we have simply never observed before because we have never looked at this exact location under these exact conditions. Or they could be something else. And the only way to know is through continued observation and analysis, not speculation, not predetermined conclusions, just patient, careful science. By December 22nd, 3 more Mars orbiters have imaged the region. All confirm the extension of the features. All confirm the spectroscopic changes. None can explain why it is happening. NASA schedules a teleconference for January to discuss potential Perseverance rover observations of similar features elsewhere in Jezero crater. If these patterns are widespread, that would suggest natural processes. If they are unique to the region where 3I Atlas was visible, that correlation becomes harder to dismiss. Chapter 21. The Psychology of Uncertainty. Let me step back from the data and talk about something that does not get discussed enough in science communication. How humans process ambiguous information about potentially extraordinary events. We want clarity. We want definitive answers. We want experts to tell us, this is what it is, with certainty and authority. But real science does not work that way. Real science operates in the space of uncertainty, gradually accumulating evidence that tips probabilities in one direction or another. Rarely do we get clean, unambiguous proof. Usually we get data that is consistent with multiple interpretations, and we have to decide which interpretation best fits the totality of the evidence. 3I Atlas exists in this uncomfortable space. The evidence is real, the anomalies are documented, but none of them, individually or collectively, proves artificial origin. They are just puzzling, unusual, not impossible to explain naturally, but requiring multiple coincidences and special conditions to make the natural explanations work. This creates a psychological tension. Our pattern-seeking brains want to resolve the uncertainty. Some people resolve it by accepting the simplest natural explanation and dismissing the anomalies as not that unusual once you account for selection bias and incomplete knowledge. Others resolve it by accepting the artificial hypothesis and dismissing contrary evidence as cover-up or ignorance. Both approaches are unsatisfying because both require cherry-picking data. The natural explanation works if you downplay the statistical improbabilities. The artificial explanation works if you downplay the lack of definitive technological signatures. The mature response is to hold both possibilities in mind simultaneously, without committing prematurely to either. To say, I do not know, and mean it. To accept that some questions do not have clear answers, yet. And that is okay. But that is hard, especially when the stakes are potentially civilization-level significant. Dr. Catherine Denning, an anthropologist at York University who studies human responses to potential contact scenarios, published an essay on December 21st titled Living with Cosmic Ambiguity. The 3I Atlas situation represents a new category of human experience, she wrote. We have physical evidence of something from beyond our solar system. We can observe it, measure it, study it, but we cannot definitively categorize it. And we may never be able to, because the object is leaving and will be gone within months. This is different from the theoretical discussions we've had about potential SETI signals. This is a tangible thing, present in our space, exhibiting behaviors that challenge our models. And we have to decide how to live with the uncertainty of not knowing what it truly is. I worry that the polarization we're seeing, the insistence on either definitely natural or definitely artificial, reflects our inability to tolerate ambiguity. We're forcing binary conclusions onto non-binary data because living with "I do not know" is psychologically difficult. But learning to live with uncertainty might be the most important skill we can develop as we enter an era of increased interstellar object detection. Because they won't all be unambiguous. Some will be clearly natural, some might be clearly artificial, and many will be exactly like 3I Atlas, fascinating, puzzling, and ultimately inconclusive. Her essay was shared widely in academic circles. It articulated something many researchers felt but struggled to express: frustration at the premature certainty on both sides of the debate. Science thrives on uncertainty. It is the fuel for investigation. The fact that we do not definitively know what 3I Atlas is should be energizing, not anxiety-inducing. It means there is more to discover, more to learn, more reasons to build better instruments and develop better theories, but only if we can resist the urge to declare victory prematurely. Only if we can accept that some mysteries take time to solve, and some may never be solved to everyone's satisfaction. Chapter 22. The Final Approach to Earth, December 19th, 2025. The moment astronomers have been waiting for. 3I Atlas makes its closest approach to Earth at 1.8 astronomical units, about 270 million kilometers. Still far away by any practical measure, but close enough that parallax measurements from different locations on Earth become significant. Close enough that we can determine the object's position and velocity with extreme precision. Observatories around the world coordinate their observations. Northern Hemisphere facilities track it through the early morning hours. Southern Hemisphere stations pick it up as Earth rotates. The coverage is continuous, comprehensive, the most intensive observation campaign ever directed at an interstellar object. The data streams into the minor planet center in real time, positions accurate to hundredths of an arcsecond, velocity measurements precise to centimeters per second, spectroscopic data capturing the faintest emission lines. And when all the data is compiled, when the trajectory is refined to the highest precision achievable, the conclusion is definitive. 3I Atlas is following a pure gravitational path within measurement error. No non-gravitational acceleration detected. No evidence of course corrections. The object is behaving exactly as a natural body should behave under the influence of the sun's gravity alone. For most of the astronomical community, this is the final word. The lack of trajectory deviation rules out active propulsion. Whatever 3I Atlas is, it is not currently maneuvering. It is not changing course. It is following a ballistic trajectory. But here is what that conclusion does not address: the chemical anomalies, the trajectory coincidences, the mass problem, the Mars surface changes, the timing of the perihelion alignment. All of those remain unexplained. Saying it is not currently maneuvering is not the same as saying it is definitely natural. It just means that if it is artificial, it is not using propulsion in ways we can currently detect. Amateur astronomer John Flannery, who has been tracking 3I Atlas since July, publishes a detailed analysis on his astronomy blog on December 20th. "I've been doing orbital mechanics for 30 years, he writes. I've calculated trajectories for hundreds of comets and asteroids. I understand how gravity works, and I can confirm that 3I Atlas is following gravitational motion right now. But that doesn't explain how it got onto this trajectory in the first place." The probability calculations Loeb published are correct. The alignment with the ecliptic, the planetary encounter timing, the WOW signal direction, all of those are statistically improbable. What I'm saying is, the object might not be maneuvering now because it already maneuvered into this trajectory earlier. Maybe years ago, maybe decades ago, maybe before we ever detected it. If you wanted to visit a solar system, you wouldn't wait until the last minute to brake. You'd plan your approach trajectory carefully, make your course corrections while you're still far out, then coast in along a gravitational path that looks natural. That's what an intelligent mission design would do. And it's exactly what we're observing. His analysis is speculative, but technically sound. It articulates something that the professional papers carefully avoid: the distinction between not currently maneuvering and never maneuvered. We can only measure the current trajectory. We cannot measure what the trajectory was before we started observing. If 3I Atlas made course corrections any time before May 2025, we would have no way to detect them. And if those earlier corrections positioned it onto the statistically improbable trajectory we are observing, we would see exactly what we are seeing: an object following pure gravitational motion now that arrived with extraordinary timing and alignment. Proving that hypothesis would require detecting an earlier trajectory that differs from the current one. But we do not have earlier data. The object was not discovered until July. Anything that happened before that is invisible to us. This is the fundamental epistemological problem. Absence of evidence is not evidence of absence. Not detecting maneuvering does not prove. Maneuvering did not occur. It just proves we did not see it. Chapter 23. The Science Communication Failure. By late December, the disconnect between scientific conclusions and public perception has become a case study in failed communication. Scientists say, "We observe no evidence of artificial origin. The object behaves consistently with natural cometary bodies, within current measurement capabilities. The public hears, 'It's definitely just a comet. Nothing weird here. Move along.' But that is not what scientists are actually saying. The careful caveats, within current measurement capabilities, no evidence versus evidence of absence, get lost in translation. And when scientists then acknowledge the anomalies, the public hears a contradiction. Wait, you said it's just a comet, but now you're saying it has unexplained characteristics? Which is it? Both things are true simultaneously. The object shows characteristics consistent with natural comets: outgassing, coma formation, brightness variations. It also shows characteristics that do not match our models perfectly: chemical composition, trajectory timing, mass estimates. These are not contradictions. They are the messy reality of observational science applied to unique objects. But communicating that nuance is nearly impossible in an environment where people want definitive answers and where social media amplifies the most extreme positions. Dr. Phil Platt, astronomer and science communicator, addresses this directly in a blog post on December 23rd. "I've been getting emails asking me to just tell people the truth about 3I Atlas. Some want me to confirm it's aliens. Others want me to debunk the alien hypothesis completely. But the truth is more complicated than either extreme. The truth is, we don't know everything about this object. We have data that's consistent with it being a comet. We also have data that's unusual for comets. Both things are true. Science doesn't always give clean answers. Sometimes it gives provisional conclusions with caveats. Sometimes it gives, 'We need more data.' Sometimes it gives, 'This is weird, but probably natural.' That's where we are with 3I Atlas. Probably natural? Definitely weird. Need more data. Not a satisfying narrative for anyone, but it's honest." His post is shared thousands of times. The comment section becomes a microcosm of the larger debate. Some praise him for intellectual honesty. Others accuse him of fence-sitting. Others claim he is part of the cover-up for not endorsing the artificial hypothesis. Everyone wants certainty. No one wants to live in the gray zone of probably, but not definitely. But that is where we are. That is where we are going to stay. Because 3I Atlas is leaving. Closing. The departure. January 2026. 3I Atlas moves outward from the Sun, its brightness fading as distance increases. By mid-January, it is magnitude 13, requiring moderate-sized telescopes to observe. By February, magnitude 14, accessible only to serious amateur equipment and professional facilities. On March the 16th, it will pass within 54 million kilometers of Jupiter, close enough that Jupiter's immense gravity might alter the trajectory slightly, close enough that some scientists have speculated about deploying instruments aboard the Juno spacecraft to observe if mission parameters allow. After Jupiter, the outer solar system, crossing Saturn's orbit by 2028, Neptune by 2035. The heliopause, the boundary where the solar wind gives way to the interstellar medium, sometime in the 2040s. Then, nothing. Interstellar space, the void between stars, where objects travel for millions of years in darkness, following paths determined by ancient gravitational interactions. We will track it as long as we can. The Vera Rubin Observatory will maintain observations until the object becomes too faint for even its powerful cameras. Radio telescopes might detect radar returns for a few more years. But eventually, 3I Atlas will fade beyond detection, leaving us with data archives and unanswered questions. Future civilizations, if humanity survives that long, might look back at our observations and understand things we missed. They might have better instruments, better models, better frameworks for interpreting anomalous data. They might know definitively what 3I Atlas was. Or they might face the same uncertainties we face because some questions may not have answers. Some mysteries may remain mysterious, no matter how sophisticated our tools become. What did we learn from 3I Atlas? What should we take forward into an era where interstellar visitors become routine rather than exceptional? First, the universe is stranger than our current models accommodate. Objects from other star systems do not necessarily behave exactly like objects from ours. Chemistry varies. Formation processes vary. What seems anomalous might just be unfamiliar. Second, statistical improbability is not the same as impossibility. Unlikely things happen. When they do, we should investigate thoroughly before concluding they must be artificial. But we should also not dismiss genuine puzzles just because accepting them as real challenges our assumptions. Third, absence of evidence is not evidence of absence. Not detecting something does not prove it is not there. It proves we did not detect it. That distinction matters enormously when evaluating claims about potential artificial objects. Fourth, living with uncertainty is a skill we need to develop. As our instruments improve and we detect more interstellar objects, we will encounter more puzzles. Not all will be resolvable quickly. Some may never be resolved. Learning to function effectively despite uncertainty is crucial. Fifth, communication matters. How we discuss uncertain findings with the public shapes how civilization responds to potential extraordinary discoveries. Oversimplifying damages. Trust. Overcomplicating prevents understanding. Finding the balance is difficult, but essential. On January 15, 2026, Avi Loeb publishes a final essay on 3I Atlas. Not a scientific paper, a philosophical reflection on what the object represents, regardless of its nature. Whether 3I Atlas is natural or artificial, its visit has changed us, he writes. We are now aware that objects from other star systems pass through ours with regularity, that the space between stars isn't empty, but populated with travelers carrying information about distant origins. We've learned that our instruments are capable of detecting these visitors and characterizing their properties in detail. We've learned that international cooperation on observations works when properly coordinated. We've learned that our theoretical models need refinement to accommodate the diversity of interstellar materials. Most importantly, we've confronted the reality that some observations don't yield clean conclusions. That nature, or whoever sent 3i Atlas, doesn't always provide unambiguous answers. That science is a process of gradually accumulating evidence and refining understanding, not a series of dramatic revelations. The object is leaving now. Soon it will be invisible to us, continuing its billion-year journey through the galaxy. Whatever it is, wherever it came from, it reminded us that we are part of something larger than ourselves. That our solar system is not isolated, but connected to the broader cosmos through travelers like this. That's worth remembering, long after the object itself is forgotten. If something was building on Mars, we do not know what yet. If 3i Atlas carried a message, we did not decode it. If it was a probe from another civilization, it completed its observations and left without making contact. Or it was just a comet. Strange, yes. Unusual, certainly. But natural. A piece of another planetary system, ejected billions of years ago, traveling through the galaxy until random chance brought it through ours. We may never know which interpretation is correct. And perhaps that is fitting. Perhaps the universe is not obligated to provide clear answers. Perhaps mystery is the natural state, and certainty is the rare exception. December 31st, 2025. Final observation of the year. 3i Atlas appears as a faint smudge in long-exposure images from the Gemini North Telescope. Magnitude 13.8. Receding. Still visible, but fading. By January, it will be gone from casual observation. By February, beyond most amateur equipment. By March, after the Jupiter flyby, accessible only to professionals with large apertures and patient tracking.